When a huge passenger plane flies above the clouds, have you ever wondered how this huge machine made of iron and aluminum floats in the air? Especially, what is the function of these gigantic engines hanging under the wings? The matter is actually very simple, which we saw when we were children blowing up balloons. According to Newton's law of thirds, the direction in which air is expelled from a balloon is the opposite of the direction in which it is expelled. Jet engines work on the same principle, but in a much more powerful and controlled way. Engineers explain the entire process in 4 very simple words: suck or pull, squeeze or push, frog or explode, and blow or release. Let's take a look inside the engine. A turbofan engine has 4 main parts: the fan, compressor, combustion chamber, and turbine. First, the huge titanium fan at the front sucks in a huge amount of air. Interestingly, in modern engines, about 80% of this air bypasses the main part of the engine. This is called bypass air, and it does the main job of propelling the aircraft forward or creating thrust. The remaining 20% of the air enters the belly or core of the engine. Here begins the second stage of the squeeze. Thousands of blades of the compressor catch the air and push it forward. As the tunnel begins, the pressure on the air increases. This intense pressure increases the density of the air and the temperature increases dramatically. The air then turns into a hot explosive gas. Now it's time for the third and most powerful stage: the frog or combustion. When this hot air enters the combustion chamber, jet fuel is sprayed there. The air temperature is already so high that a controlled explosion occurs as the fuel mixes with it. This is no ordinary fire. The temperature here rises to 1000 to 1500 degrees Celsius. This air, burned by the fire, now starts to rush to get out. As it rushes backwards, it spins the blades of the turbines in its path at high speed. And this is where the real magic happens. This turbine is connected to the front fan of the engine through a long rod or shaft. That is, the faster the rear turbine rotates, the faster the front fan draws air. This is an automatic cycle. The fourth step is blow. After the turbine spins, hot air is forced out of the rear nozzle of the engine at high speed, which pushes the plane like a rocket. But the question is why the engine's rotor blades don't melt even under such intense heat? The reason is a matter of engineering. If you look at them through a microscope, you will see that there are thousands of tiny holes on the blades. Cold air escapes through this hole, protecting the blades from the fire. When the plane stops on the runway, the pilot increases the engine power. The heat of the fire and the pressure of the wind cause the plane to defy gravity and spread its wings into the sky. While you sit by the window and drink coffee, this engine outside takes you safely to your destination. This power is controlled from the cockpit by the pilot's hand signals. When you look at the night sky, you can often see the glow of fire behind the engine as scientists are constantly trying to make it more powerful, silent, and fuel efficient. When the plane disappears into the sunset, it carries not only the passengers but also the unquenchable dreams of people. Subscribe to our channel to